Okay, now let's river boat concept. Green color. This river current, velocity of river. So few terms are there. We'll define them. What is VR? Velocity of river with respect to ground. If I write velocity of boat or swimmer, velocity of boat or swimmer, it is. This is velocity of boat with respect to ground. VBR, if I write it, let me use all the symbols possible. Velocity of swimmer with respect to ground. VBR will be velocity of boat with respect to river. VSR will be velocity of swimmer with respect to river. Okay, these are the popular terms which I'll be using. VBR already you know, VAB, VA minus VB bar. So what is it, this entire concept? Velocity of swimmer with respect to river equal to velocity of swimmer minus velocity of river. Oh, this topic is over. No need to bother. That you can straight away go to numerical and start working. Apply relative velocity along X, along Y and work out. This is a core idea. I'm telling this one. Pretty sure. There's no need to even read theory also. Straight away, you know relative velocity, you know kinematics, you know displacement, velocity equal rate of change of displacement. You have to apply. So this is what your entire idea revolves around this. I'll begin like this. Now, what is everything? So there's a bank. There's a bank. And there's another bank. There's a at point A, I'll start it. At t equals 0, the starting point will be this one. So where I'll begin from bank, I have to cross the river. So if the swimmer, as he'll start from one bank, if the boat, he'll start from this particular bank. So bank, what happened? You just show like this. I think I should not use word shore, no. Seashore, it's called as river shore. We should not use river bank. We have to call this. So there's a bank. And what about this? This is opposite bank. Where you start, there'll be a bank. Where you reach the other bank, no, that's called as opposite bank. So there is a point exactly opposite to the starting point, will denote by symbol B. Now how the river flow? The river flow is like this. VR. River current, it is also called as width of the river, W. These are the symbols we'll be using. Now velocity of swimmer with respect to river. He will swim yeah, take like this. What do you mean by velocity of swimmer with respect? So the swimmer weapon will jump into the river, he will dive into the river. When he puts his head into the water, no, he feels he's moving in this direction. He feels he's moving in this direction. So let me take that as theta. He'll make some angle with the reference line AB. So that is VSR. What is this VSR? Velocity of swimmer with respect to, or velocity of boat with respect to river. What about velocity of swimmer with respect to ground? So here the river current will push him. So the resultant velocity will be somewhere here. This is what VS. Now, so you ask the person here, you are the swimmer, where you are heading. You say that when you're swimming in the river current, you ask him where you are going to reach. You say, I'll reach D, point D. Then, but what you say? You said, no, you'll reach at C, that one. So what is VS? Velocity of swimmer with respect to run. So what is this red color path? Path with respect to bank or ground. What about this? Path of path of what? Path of swimmer, here, path of swimmer or boat with respect to river. So when that swimmer is swimming in the river current, when the swimmer is swimming in the river, he will put his head into the water, no? Then he'll be swimming. Ask him where you are going to, how you are moving. He say, I'm moving along the path area. When he lifts his head and looks at the bank, then he feels that he is moving along AC. VS is velocity of swimmer with respect to ground. VSR is velocity of swimmer with respect to river. I think the sentence itself is there, no? With respect to river. Fine. I think I'll write it. Okay, look at this. So now there's a path with respect to ground. So here, the swimmer will be here. There's only one swimmer. Don't think that there are two swimmers will come. There is only one swimmer in there. Okay, let me give it a red color. It'll be easy for you. So the another person. Look at now. The swimmer, what happened when he puts his head into the river, he feels he's moving along the path area. When he lifts his head and looks at the bank, no, he feels moving along AC. Why that is? Because the river current will push him. The river current will push him. The river current will push him. So what is our question? Shall we take this a drift? What do you mean by drift here? So he was pushed along the river current, no? So that particular quantity will become a drift. Then you'll start at t equals 0. You will reach here after some time. So what is the time taken to cross the river? We'll find out all the quantities. Now, if the boat, let it be instead of swimmer, no, let it be a boat. Tell me which quantity you can measure. VR, can you measure S? Using fluid mechanics, I can measure VR. Can you measure VSR, VBR, velocity of boat with river?
నెట్ రావట్లేదు ఇంట్లో ఇప్పుడు ఇంతవరకు వచ్చింది ఇప్పుడు రావట్లేదు.
Nitesh, can you hear me?
Yes, sir.
Okay, no problem.
Yes, sir. No problem, sir. Thank you.
VSR, this VR and VS bar. So now, let VBR. So which quantity are measurable? VR measurable. I'm writing some few very basic terms. VR measurable. VBR. Sir, how you measure VBR? I think nowadays we have got mobiles. A boatman, we'll call boatman. What is the speed of your boat? What is the speed of boat? Please need not to suggest anything, please. Huh? Let me, because when I get a chart, no, I feel some doubt is there. So no need of any suggestion, nothing. Carefully, happily you listen first. Even if you know some concept also, have patience to listen first. No need to share. You are not a position to share anything. Try to understand things in different way. VR is what? Velocity of river measurable. With the help of fluid mechanics equipments, I can measure velocity of river current. Okay, there's no problem with this. What is VBR? Say a boat is moving in a river. I'll call boatman. What is the velocity of your boat? You look at the speedometer of boat, you say there's a speed, and you will tell also the direction in what way I'm moving. So VBR is measurable. What is VS or what is VB? VS is the velocity of the boat or the swimmer measured from the ground. Can you measure? Not possible, no? For this, what you should do? By being on the bank, you should measure the displacement of swimmer and the time taken. Divided by time taken will give the velocity. Is it possible for you to standing on the bank and measuring the displacement? I think very difficult, no? Of course, technology improved, still it's very difficult. Exactly, it's very, a lot of error will come. So I better let me put, we are at 300 years back, so are not measurable, finish over. Or 200 years back are not measurable. So therefore, I should not bring any quantity in terms of VB and VS because as it is not measurable. This is one basic rule there in the river boat. That's why we are not taking help of VS because the quantity cannot be measured. So no question of expressing any unknown in terms of that one. Getting the basic idea of this. What is the problem? Can you measure the displacement of swimmer being on a bank? You are on a bank here. You are a person. Can you measure displacement who is some half kilometer somewhere from away from you? Can you measure the displacement exactly? Can you, so no sir, I'll get into the river. VBR, boatman, I'll call boatman. The boatman will look at the speedometer, you'll say like, okay, with what speed the boat is moving and also the direction. Finish or no? Quite simple. Is it okay? VBR, VSR, very, very simple. I'll call swimmer with what speed you are moving. Okay, best than swimmer, no, take help of boat. The speedometer of boat will indicate VBR. And the direction of the boatman will tell what direction is heading in the river current and we'll get VBR. Fine. So what is our discussion now? Our answers, what are answers? How much of time will take to cross the river? Then what is the drift? The text is called like a drift here. So here, the quantities here will call as a drift. What do you mean by drift? The displacement of an object under action of a force is called as a drift. The displacement of an object under influence of a force is called as a drift here. See, I should have used the word displacement, but it's not a displacement. Is it unwanted or wanted? Unwanted, no, the river current will push a forced displacement or displacement under influence of force is called as a drift. The technical meaning of that. And what is W here? We used width of the river. These are the terms which I'm using. So let's come for directly the question, like what is the time taken? So I told you, no, I'm going to take help of this formula. I'm starting it here. VSR equal to VS bar minus VR bar. Let me write this along X along Y. So VSRX equal to relative motion along X-axis. Let me write. What is VSX? Velocity of swimmer with respect to ground along X-axis. What are X and Y-axis? This is X and Y-axis. Similarly, let me first find out the time one. I'll come to this. Drift, displacement of an object under influence of force is called as a drift. What is the force? The river current will push, no? That's why we use word drift. How much of displacement along the bank? What is the drift? How you measure? Displacement along the bank. Okay, got it, no? So let's go for this one. VSRY equal to VSY minus VRY. Will I agree this? The vector form. What is VSRY? Looking at the diagram, VSR cos theta. What is VSY? Velocity of swimmer with respect to ground along y-axis. VRY, how the river is flowing along x-axis. What is VRY? Is zero, no? You can see from the diagram, river is flowing along x-axis. So what is VSY is equal to? VSY equal to VSR cos theta. Okay, no. The time taken, who will determine the time taken to cross the river? Time taken is equal to W by VSY. Who will determine time taken to cross the river? The vertical component of swimmer along, or the y component of swimmer with respect to ground along y-axis. That will determine time taken to cross the river. So what is VSY? W by VSR cos theta. So what is T I should write? Time taken by swimmer to cross, time taken to cross river. Is it okay? I think this is the concept. Don't bother the end formula. This is the concept. Who will determine which component of velocity of swimmer will determine time taken? Vertical component, VSY. I wrote it here. Let's come for that. How much horizontal displacement or displacement along the bank? That will be. Let's apply the same formula along x-axis. I will continue the discussion here. So shall we break up this VSRX? VSRX equal to VSX minus VRX. So this will be VSRX. So these are very important. I'm telling this one. The whole concept is this VSRY equal to this one. I think rest everything you can manage. There's an idea. I just shading them. I'm highlighting that one. Please do concentrate on this. Finish over. The rest of everything you know, uniform velocity motion, all other kinematics, you know it. You can manage. It's very, very pretty easily. You can manage all other things here. The core idea is what you just put effort. Every numerical, there's an approach. It's not like something. Not only here, every numerical you can take help of this. Tell me, who will determine the displacement? The x component of velocity of swimmer with respect to ground. Shall I write like this? X equal to Vsx into t. What is the time taken? Time taken to move from A to C is what t, no? In that interval of time, you'll have a horizontal displacement of x. What is Vsx? Substitution of this. Okay, now so we'll substitute value of Vsx. So this will be Vs Rx plus Vrx into t. I'll slide it. I'll slide down. Okay, no. That so what you should call no. What is this? This is a drift. In the end, I'll write it. Now, what is VSRX? VSR sine theta plus VR. Sir, why you are writing VRX equal to VR? That's what no, VRY is 0. How the velocity river is flowing along x-axis. What is the expression for time? W by VSR cos theta. So what is this x is called as drift. So who will determine the time taken to cross the river? VSY, finish. Who will determine time taken to cross the river? VSX. And this is the next, I'll highlight in red color. Every numerical, your approach should be only this one. So how to calculate VSX and VSY depends on the situation. Finish over. There's a theory. So in the books, what happened? They have started not with this idea. So why you find this very difficult? They didn't brought this VSRY, VSY, that one. They're just telling that directly they're writing this one. T equal to the time taken to cross the river depends on VSR. I think there the trouble will start. So better what happened? We have to begin from here. VSY will determine time taken to cross the river. VSX will determine the drift. Finish out. You need not to bother after this any other thing. Let whatever the type of numerical you can manage. Any doubts you can clarify, because there's a basic idea, because every numerical I'll be taking help of this condition only. All of you okay? The terms. I defined all the terms in some books. They started with VBR. That's why I brought that also. Either boat or swimmer. Let it be same. Any doubt you clarify? So then I'll proceed for the next conditions. Shall I scroll down?
Yes.
Now look at the formula. How is, shall I say, down the stream? Is swimming down the stream. So when you're swimming down the stream, these are the equations. When you're swimming down the stream, these are the equations. So what all we discussed. So what are this? The drift and the time taken to cross the river when he's swimming down the stream. Let me swimming when swimmer swims down the stream. What do you mean by down the stream? Why we should call like that? So look at the VS, how it is. Component of VS is one will be perpendicular to river current, other will be along the river. No, so this particular thing means you will start at a, finally you will reach down the stream. No, where is the point C? You see point C is on the left side of the starting point, right side of the starting point. So therefore I should call down the stream. So there's a condition I brought it. So whenever you swim down the stream, no, so these are the equations you are going to take help of. So let's go for when he swims up the stream. When swimmer swims up the stream, what conditions are there?